Okay, so this is just a quick video to go over the skill of counting protons, neutrons, and electrons given certain information. So for this, the most important tool we're going to have is the periodic table. So you have your periodic table for this class that we're going to use right here. And I want to start by looking at the information that's given to you at the top. So if you look here at the top with silicon as an example, it actually tells you in the key what each number means. Okay, so for the purposes of this activity, we're going to use the atomic number. So for silicon, that's 14. So make sure that if you forget where to find these things, you always just look at the key, right? Because that can really help you. Okay, so we want to know how to find the protons, neutrons, and electrons in a given atom. So let's take as an example nitrogen, okay? Now, if I look at nitrogen here, I know that no matter what, nitrogen is always going to have 7 protons. Okay, and the reason that I know that is that that's the atomic number. So the atomic number always gives you the number of protons. So just by knowing the identity of an element, I know how many protons it has. Phosphorus, 15 protons. Fluorine, 9. Okay, so finding the protons is really easy if you have a periodic table, which you always will. Now, today we're just going to talk about neutral atoms, which means they have no overall charge. Hopefully you remember that protons are positive and electrons are negative. So if the atom has no overall charge, you can probably guess that the number of protons and electrons are the same. Okay, so let's look at nitrogen again. We said nitrogen had 7 protons, right? So if it has 7 protons and it's a neutral atom, then it must have 7 electrons as well. Okay? Now, I'm going to erase this to talk about neutrons, because neutrons are just a little bit more complicated. Now, you might notice that if you look on the periodic table, you also have the mass. But the mass isn't a whole number, okay? And that's because the mass that's on the periodic table is what's called a weighted average. And we'll talk about that later. You don't have to worry about it yet. But basically what that means is that you can't use the mass to determine the number of protons. Now, or excuse me, the number of neutrons. So, the mass number for a specific atom is equal to the number of protons plus the number of neutrons, okay? So we have something called isotopes, and isotopes of an atom have the same number of protons but a different number of neutrons. So if they have a different number of neutrons, that also means they're going to have different mass numbers, right? So I'm going to give you 2 examples. I'm going to give you 2 isotopes of chlorine. So chlorine with a mass number of 35 and chlorine with a mass number of 37. Okay, now, if we look at the periodic table, chlorine has an atomic number of 17. Okay, so we know that chlorine 35 has 17 protons. And so does chlorine 37. It's always going to have 17 protons because that's the atomic number. Where it's going to differ is in the neutrons. So if I want to figure out the number of neutrons in this isotope of chlorine, chlorine 35, I would say 35 minus 17, there's 18 neutrons there. And for chlorine 37, I would say 37 minus 17, so there's 20 neutrons there. Okay. Now, electrons will also be equal to the number of protons here. So this would also be 17 for both of these. Okay. One other thing that you might see sometimes, we wrote the isotopes with the similar the name and then a dash the mass number. So you can write it like this: chlorine 35, chlorine 37, or you can write chlorine 35, chlorine 37. And either way, this number is the mass number. And remember, the mass number is equal to the protons plus the neutrons. Okay? All right, so you should have enough information to try some of the questions in the homework. And if you get stuck, you can look at the longer lesson or you can send me an email.